Welcome to my Chess Kotlin CLI tutorial. This is part 1 of the playlist and will focus on creating the interfaces and the class for the chess game. I want to start off by showing you the class diagram. These classes and interfaces serve as the backbone to the chess game. We have an independent interface class called the piece type, which will be depended on by the multiple piece types that each piece can be. One piece type is the knight, another is the queen, another is the pawn, another is the black pawn, another is the bishop, another is the knight, the king, and another is a rook. The next data class that depends on piece type is piece. Piece contains a name parameter that describes the piece's player and piece type, such as white pawn. Piece type is the piece type for the piece. Initial position is the piece's initial position, which is of type position, which is defined here. Position is the piece's current position, which is also of type position. Open moves is a set of the piece's open moves. Then we have position, which is defined up here and is independent. Piece and player both depend on this class. Then we have player, which depends on piece and position. Board is dependent on player and piece and defines the methods used for the board, while game is dependent on board and player. I will explain all of the parameters and the methods shown here while I'm implementing each data class. Also, the player does have two data classes that are dependent on the interface. The two are black player and white player. Okay, now let's get to implementing. The one that I'll start implementing first will be piece type. So what I'm going to do is I'm going to first delete this file and I'll create a new folder, a new package actually. And I'm going to name it common model piece types. We have to stick to naming conventions by making everything lowercase. For the package name. Now I'm going to create a new Kotlin file, and this file will be the piece type interface class. Okay, now that we have the piece type interface class, we want to define the parameters for the piece type. So piece type has 3 parameters and 2 methods: move pattern and copy. So let's first define the 3 parameters. We have val, name, string, val, point, int, val, image, string, keep as letter, can turn into image, maybe, if needed. But actually, I'll just remove that, keep it lesser. Okay, now that we have the parameters, we want to define the methods. So the 2 methods that we have are move pattern and copy. So essentially, move pattern is going to help us determine the move pattern for specific piece types, and copy will just allow us to create a copied instance of the current piece type. Okay, so now that we have move pattern and copy function, let's define the input parameters. So the first input parameter will be position. And the next, we're not going to be using Java X Wing text. We're going to define our own position data class. The next input parameter will be player piece positions. Then other player piece positions. And other player all open moves. Okay. So these are going to be the input parameters. I'm going to explain all of these input parameters will make more sense once we're actually implementing each piece type and each piece type's move pattern. And for copy, we're not going to have any input parameters. All we're going to have is an output type, which is piece type. Okay, now that we have our interface created, we can create our data class. Okay, the first one we're going to be creating is the knight. New Kotlin class. We're going to make it a data class. And it's going to implement the piece type interface. Okay. So Intellij makes it easy to implement the constructor parameters that will ensure that this data class meets the contract requirement for piece type. So all I need to do is just click on this and click OK. And now we have all the constructor parameters. And that we can also implement the members for that piece type implements. Okay. So what I'm going to do is I'm going to create all of the piece types, and I'm going to implement all of the construction parameters and all of the members the piece type implements. We technically have all the piece types, but there's one more piece type that we need to add, which will be the empty piece type, which will be the empty spots on the board. So I'm just going to add that too, and it will also implement the piece type interface class. Okay, now all I need to do here is I need to implement this. Let me order it. I need to implement the members. now that we have all of the constructor parameters and members implemented, we can now define them one by one. I guess it'll be easier to define the constructor parameters and the members for the empty data class. So the name will be empty. The point will be 0. And the image will be an underscore. And this should return a set. And this will return an empty set. So it turns out move pattern is meant to return a set position, and this would, because this move pattern will help us determine the open moves for each piece. So we need to make a change in our interface to ensure that a return type of set position is returned. And our copy function is going to return an empty data class. Okay, so this is basically what we're going to do for every other piece type. But I guess before we move forward, it will help for us to create another class, data class called position, so that we don't see all of these red marks around our code. And I'm going to create a new package. It's going to be out of piece type, and it's just going to be position. And the class will be called position, and it's going to be a data class. Okay, now that we have our data class, let's define the parameters that will be in position. We'll have a row column. This is a basic representation of what is going to be in position. We are also going to have another variable called pawn forward move, which will be a boolean, and this is essential for determining if the move is a pawn forward move, where the pawn needs to go 2 spaces. And then we're going to have toString and toString without p, just so that we can remove that extra p that's going to be added in our toString function for pawn forward move. I'm going to explain a lot more about it while we're implementing it in position. So the first parameter is row, the next is column, and the next is bar, pawn forward move. Okay, so we have our constructor parameters. Now let's add the members. Every data class has a toString member, so we can override it to make it our own, implement our own toString method. And what we're going to do here is we're going to check if the position is a pawn forward move, and if it is, we're going to return a string. Column row that contains the column definition, and the column definition it's going to be a letter from A to H, and the row is going to be a number from 1 to 8. And then if it's not a pawn forward move, we're just going to return column row. In some cases, we're not going to want to have the P when returning the column, when returning the position as a string, so we can make sure that the position loses the P by calling this function to string without P. Okay, we have a position defined. Now let us import it in our data classes. Okay, now that we've imported position in all of our data classes, let's start implementing the move pattern for each data class and the parameters. Basically, we're importing everything. We're going to start defining everything for each data class for piece type. Okay, we're going to start off with knight. So the knight can have a name of knight and a score of 3. And an image of n. Now, for defining the move pattern, so to define the move pattern, we need to create a list or a set of all the positions that are valid for this piece type. So within this function, we can have another function, helper function, that adds to a set that we defined initially, and that set that we defined is going to be returned from this function. So the set that we're going to define initially is called valid position, and I'm going to define it here. Valid positions, and it's going to be a mutable set of positions. Okay, we have our valid position, and before I define the helper function, I'm just going to put it here. So the knight moves in an L shape, so the only positions that are valid for the knight are positions that are an L shape from the current knight's position. So one way that we can implement the move pattern for the knight would be to use an offsets, which will help with determining what positions are an L shape from the current knight position. So I'm going to define the knight offset over here. Which is going to be a list of -2, -1, 1, 2. And this is basically saying, okay, the knight can move in 2 spaces in one direction, and then in one square perpendicular to that. And that's the same with 1 and then 2. Of the number will be explained more vividly while I'm implementing it here. So what we have now is a for loop that's going to go through each element in the knight offsets. So for example, it's going to start at, the column offset is going to start at -2. So this would mean that the column would, the offset will go to the left of the board, and then the row offset would be -2, but then because it's a knight, it can only move 2 spaces one direction and then 1 another direction. So the absolute, if the knight offset, the column offset is the same as the absolute of the row offset, then we're not going to include that move. We're using the Kotlin absolute function. And at the end of the function, we're going to return the valid positions. Okay, so we've defined the offsets that are valid. Now we need to define what determines if the move is a valid move. So for our function, the input parameters are the column offset and the row offset. We need to define this two-column number. This function would convert the column from a letter to a number, which is needed here for determining if the move is valid. So what we're going to do is we're going to define that function in a new file. And this will just be function to column. Okay, so this is our two-column number function, and it's an extension of the string class. So we're essentially adding a new method for a string class, and this method will return a number depending on what the input string is, or what the actual the value of the string is. So when the string is in A to H, then what will be returned would be the character, the first index of the string, which would be an A or B or C, and minus the letter A. So this expression will output an int. But if the letter is not in between A to H, then an illegal argument exception is thrown with this message. Okay, so this is our new column based off of the column offset. So we're going to add the column offset to the current position of the piece, and we're going to add 1 because the output of our two-column number is dependent on the difference between the letter to A. And if for example, if the letter is A, the output would be a 0, but we want our index to be 1. And the reason why we want it to be 1 will be shown later. And then we are going to define our new row, which is the positions row and plus the row offset. Okay, so this section of the helper function is going to add the new row and the new column if the new column is within 1 to 8 and the new row is within 1 to 8, and the new column and the position of the new column and the new row is not contained within the other player's pieces. So the other player does not have a position, another piece at the position that we're currently looking at the new position. The other player does not have a piece at the new position. So this if statement checks if the other player does not have a piece at the new position, and if the new positions column is within 1 to 8 and the new positions row is within 1 to 8. And if that condition is met, then the new position is added to valid position. All we need to do is add the two-column function in the utils file, which will convert an int to a column. Our function here does the same thing that two-column number does, except in this case, it checks if the int is between 1 to 9, and it checks and it turns into a string. So let's say this function basically turns an int into the column string from A to H. So if the int is 1, it's going to return A plus 1 minus 0, which would be A, and convert it to a string. A as an int, and it will convert it to a string. Now we need to import it in this class. So make this a function invocation. So we have now implemented our knight data class. We have now implemented the move pass of our knight data class. We now only need to implement the copy function, which will return a knight. With these input parameters, name, point, and image. Okay. We'll continue to implement the other members for each of the other data classes, each of the other piece type data classes. Thanks for watching this video. This is the first part of the chess game playlist. I'll continue to implement the other data classes in the next video. Please stay tuned.